Okay, good evening, everyone. So, today we are doing out of box things. We are revising or we are seeing the 100 interview question. Uh, okay, sufficient number of the interview question based on uh, digital electronics. Okay, electronics. Okay, so let's see. So first question is what there are two type of circuit. Okay, so two type of circuit. One is combinational and other is sequential. Okay, so combinational circuit, the first question arises from this set is what is combinational circuit. Okay, first question arises that what is combinational circuit circuit. So let's see what is the combinational circuit. So combinational circuit are the circuits. Let me zoom. Zoom this screen. So mm, combinational circuit. So combinational circuit is a type of circuit in which type of circuit real logic circuit which output depend on the output depend depend on the present input. Okay, present input. Okay, so in combinational circuit the output present on the present input. The combinational circuit in which the output purely a function of the current input. Okay, purely combinational circuit. Logic is a circuit where the output is pure function of the current and there is no memory. Okay, no feedback no feedback and no clock. Okay, one of the direct direct thing that we can see that any combinational circuit in which our output depend on the present input and there is no memory, no feedback and no clocks. Okay, this is the one of the key feature in which like no memory means there is no use of the and there is no use of no memory mean what no memory mean no flip flop flops. Okay, and instantaneous response after every instantaneous responses after propagation delays. Okay, and the output change immediately when the input changes. Okay, the output change immediately when the input changes. The output changes immediate after the input changes all the. Okay, and built using a logic circuit and built using a logic gate such as and or not. Okay, XOR, NAND and NOR gate. Okay, these are the right things we can expect from the combinational circuit. Also, the example of combinational circuit are the combinational circuit example are as follow. First in adder one, subtractor, adder in full and half, subtractor, multiplexer, demultiplexer. Okay, encoder, encoders and decoders. Okay, and comparators, all these things are the combinational circuit. Parity generator. So these are the example of the combinational circuit, and one by one we can see all these things. General structure, if we draw a combinational circuit in which what is the general structure of the combinational circuit is input we provide the input, there will be output. Okay, and this is the logic gate. Okay, logic gates, uh, gets. So this one is the first things. And as compare, if we compare combinational circuit with the sequential circuit, another circuit type is sequential circuit. Okay, sequential sequential circuit, sequential circuit. So sequential circuit in which we use for memory, we use flip flop. Okay, flip flops, and depend on the current, and in which the value depend on current plus past responses. Okay, past input, and any use of clock needed. Yes, in this clock also needed, clock is needed. So difference in combinational circuit depend only on the present sequential, and in which present output plus past has a memory. Okay, feedback things, clock signal, these things. But this if we compare these speed things, the combinational circuit wins. The combinational circuit is faster as compared to the sequential. Only the gate delay we can see, only the gate delay we can expect. But in the sequential circuit, we can expect slightly slower as compared to this combinational circuit, because we have the delay because of the gate, clock, and memory things. Okay, combinational circuit are very simple and simple design, but whereas sequential circuit is complex because it has include memory plus logics. Okay, combinational circuit, we see the examples are the adder, subtractor, mux, demux, encoder, decoder, comparator, and coordinator. But when we see for the sequential circuit, we see the flip flops. Okay, counter, counter, shift register, shift register. Okay, serial memory unit, and the state machine, FSM, FSM things like FSM. All these are okay. And okay, so these are the first two question. When we the next question is that what is universal gates? What is universal gate? Hmm, what are the universal gates? Okay, so let's discuss the universal gate. So universal gate are the logic gate that can be used to implement any boolean function or any circuit, data circuit using that gate. Okay, so when we have to implement any gate, implement implement any gates. Okay, implement any gate, implement any gate. When we have to implement any gate, so so at that time we use universal gate. So because we think that I and not all these are things, and NAND, sorry, NAND and nor are the universal gate through which we can make any of the gates. Okay, not gate, and gate, XOR gate, or any complex digital circuit. So NAND gate as a universal gate, you can make not or and or NOR gate as a universal circuit, you can make not or and. Okay, and next question is all the implementation based question we do in the next session. So only we see that what is adders. Let's see, design or design. mm, but for 2 minutes we are searching the more question based on this details and digital electronics. So the first question is that a comparator. So what is comparator? So let's see. Okay. So the comparator is a digital circuit that compare the two binary number and produce the output indicating that the relation is not. So comparator mean in which are comparing the two binary input. Okay, if A is equal to B, not if A is less than B, all the things. Comparator is a digital circuit that can compare two binary number. Okay, two binary number and produce the output indicating the relationship between if A is greater than B, yeah, is equal to B, A is less than B. Okay. Mm, just imagine if we are if for the one bit the output will be, so for the one bit the output are A greater than B is equal to what? A, B negation. Okay. If A less than B, this means that A negation B. Okay. If A is equal to B, this means that A XOR B. Okay. XOR, we can use this symbol as a XOR here. Yeah, we use added A XOR B. Okay. Inverter. For the AND bit, we use cascade bitwise comparator, use LSB to MSB standard and all these things. So okay. After that, these are the things. Comparator, what? No, simply comparator is a digital circuit that compares the digital input and produce the output indicating the relationship. If A is greater than B, yeah, A is equal to B, yeah, A less than B. Okay. Comparator are the digital circuit that are used to compare the two binary number. And after that, next we see difference between encoder, um, encoder and decoder. Okay. So encoder and decoder. So as we see the difference between these terms, function the feature encoder and decoder. So encoder mean many input and fewer output. Many input or fewer output. Okay. And decoder is few output as compared to in the decoder things. Let's partition line. This side we discuss all the encoders thing, and this side we and whereas in which few input but many output, okay. Decoder mean is many input but few output, and in decoder side only few inputs are there and the many output are here. So the main function this, when we see the example, okay, we see 4 to 2 encoder. A four input produce produce 2-bit code. Okay, bit code. This is only one of the example. For the decoder we can see two input two input to 4 decoder, in which it mean are 2-bit input 2-bit input select to input select one of the 4 output. Okay, output. So output style is binary representation. The output style is a binary representation. Output style is binary representation, and whereas only one output is high. Okay, one hot mean only one output is high. Only one output is high. Okay. And use of parity normal encoder ambiguous if multiple input is active. Typical keyboard encoding, interrupt encoding, or these are things. So we see the application of encoder and decoders. So encoder application for keyboard scan, code generation, parity encoder for interrupt and data compression, and decoder I mean in application memory chip selection, address decoding. So 7 segment display drivers in which we use decoders has 2 input, but fewer input but many output are there. Multiplexers, instruction, all these things. So many more question arise. Design of 4:16 decoder using 2:1 decoder. Okay, how we can implement all the steps we have to follow. What is parity encoder? So what is parity encoder? Priority or parity? Priority encoder. So priority encoder. Okay. So what is priority encoder? Priority encoder is an encoder that when multiple input, let's say in which that a multiple input, because encoder things having multiple inputs but fewer output. Okay. In priority encoder in which when a multiple input are active simultaneously, the output the binary of the highest priority active input. It also usually provide a valid or any input active flag. For example, 8:3 priority encoder. If I7 or I they both are high, the output corresponded to the I7 highest priority. Okay. So priority encoder that when a multiple input are of the highest are simultaneous in active state, the output of the binary the highest priority predefined. So okay, understand. Let's see what I'm telling to say. If an encoder, when we are talking about the priority encoder, in which when we have a multiple input having the active state, this example I7 and I3 have a highest priority or in the active state. These are in the active state. Okay. So as predefined, it select the highest priority. It select the I7 output as the I7 because it is the highest priority one. Okay. Mm, so what the next thing is, what is multiplexer? What is mux? What is multiplexer? So multiplexer mm, definition. So multiplexer things. Multiplexer, a device that select only one or many input data and forward it into the single output. Okay, and controlled by a select line. So it is a device. Okay, actually it is a device have one or many input. Okay, and input lines. Okay, a device containing one or many input line and forward it to a single unit and forward into a single output. Okay, single output and controlled by what? So controlled by a select line. Right? So multiplexer is a device in which we have to see multiplexer is a device in which we see one or many output, one or many output, and controlled by the select line and which forward a single output. Okay. The application, what is the application? Simply data routing, a bus selection, implementing the logic using mux, a universal building block. It is a universal building block. It is also keep in mind it is a universal building block. Okay. So so all these things, single selection or the test for the debugging, all the things. So why mux is known as a universal circuit? The question is why mux is known as a universal circuit? Because many boolean function can be implemented using mux. Okay. So many of the boolean function can be implemented using mux. Okay. by wiring the input 0 1 and using the select time variable. So and to the power n is to 1 mux. So when we are to the power n is to 1 mux, 1 mux can be realized by the n variable by feeding the mux the input data appropriate with the constraint, and the mux is known as the universal block because the boolean function can be implemented using only mux. A mux can be realized by only n variables by feeding the mux data input appropriate constant with a smaller subfunction. Okay, but many question arises design 4 is to 1 mux using 2 is to mux. Okay, all the design logic using and or XOR using 2 is to 1 mux. We have to see in next lecture how many 2 is to 1 mux are used to make a 64 is to 1 mux. When this question arises, uh, when the question arises how many 2 is to 1 mux, so 2 is to 1 mux is required to make 64 is to 1 mux. What? 64 is to 1 mux. So in this case, a simple logic what we have to do. So total how many mux? What we have to do? 1 2 something. 6 by 2. So a 64 is to 1 mux can be built a tray of 2 is to 1 mux. So 2 is to 1 mux reduce the lines into half. The combined 64 input into the one output, so requires 63 input line and 61 and selector of n minus 1. So simply we use 63 to input 1 mux. Okay, 63 in 1 mux. So many implementation to input and get using 4 is to 1 mux, demux. Okay, implement demux, all these things. Implement a full adder using 4 is to 1 mux. So all these are the implemented things. Okay, so we almost see everything, every definition based thing in this session. This is a 22-minute session, so let's continue our discussion based on the sequential circuit in the next session. Okay.